Hi everybody, in this video we're going to go over one of the questions that was in our last quiz, quiz 3, and it's the one about the difference quotient and is the problem that had the radical as a denominator. So let's go over that real quick. All right, so with any difference quotient, the first thing is, well, write out what is the difference quotient. So we want to simplify f of x plus h minus f of x all over h. So the first step is always finding out what is f of x plus h. So in this particular function, right, this is our f of x, so it's 1 over the square root of, everywhere we see an x, we're going to plug in x plus h. So this looks like 2 times quantity x plus h plus 1. So this is not the exact problem that it was on the quiz, but it's very similar. So that's my f of x plus h. And then f of x is still just the original function, so I don't change anything. Putting it together, then f of x plus h becomes 1 over the square root of, and we can distribute this 2 in. So I'm going to have 2x plus 2h, and then plus 1. This is still all under the radical. And then we have minus f of x. And f of x is our original function, so 1 over the square root of 2x plus 1. And then I still have the whole thing divided by h. So what we did is, here's our f of x plus h, so that's what this is. Here's our f of x, so that's what this is. And our h is that h on the bottom. So with the difference quotient, the goal is to eliminate this h from the bottom. So normally when we have radicals, we multiply by the conjugate, but here I don't have just the radicals, I have 1 over a radical. So my first step here is to get a common denominator in that numerator. Get a common denominator on the top. So, and when I say on the top, I mean this top, the top of the whole over h, right? The f of x plus h minus f of x. So our common denominator, we need to multiply this one, top and bottom, by what is missing. So the 2x plus 1, multiply top and bottom, the radical, and this one, we're missing the other. So 2x plus 2h plus 1, multiply top and bottom. And so what we'll get is the square root of 2x plus 1. Right now we're going to have the same denominator. So my denominator is going to be these two radicals multiplied together. So the square root of 2x plus 1 times the square root of 2x plus 2h plus 1. So my numerator, 1 times the square root of 2x plus 1 is the square root of 2x plus 1 minus, and then 1 times the square root of 2x plus 2h plus 1. And this is still, right, the whole thing over h. Just remember, this whole big fraction here is still our f of x plus h minus f of x. All right, so now, if this looks too crazy, too ugly, we can rewrite it. So I'm going to have 2x plus 1 minus the square root of 2x plus 2h plus 1 over my denominator. And then instead of dividing by h, right, when you have a fraction divided by another number, you can say that fraction divided by the reciprocal of whatever's on the bottom. The reciprocal of h, well, h is really h over 1. So the reciprocal of h over 1 is really 1 over h. So multiplied by 1 over h. My goal is to get rid of this h, right? That's the original h from the difference quotient formula. That h highlighted in blue. So that's my goal, is to eliminate this h. Okay, so now I do have the difference of two radicals here. So now I can use the conjugate. So I'm going to multiply by the conjugate. So which will be 2x plus 1 minus the square root of, plus the square root of 2x plus 2h plus 1. Right? For the conjugate, we change the sign of the original. So that's a minus, so in the conjugate, it becomes a plus. And you do top and bottom. And so let me write out my very crazy looking denominator now. So I still have this. Now these are being multiplied, right? So since they are the same radical, we could use the properties of radicals that say you can multiply the radicals. I'm just gonna leave them. So I'm just gonna say the square root of 2x plus 1 and continue saying times the radical of the other one. If you want to use parentheses instead, you can. So let me use parentheses for this one. 2x plus 2h plus 1. Right now times that h, I'm going to write it at the end, but now I'm multiplying this. So it's going to be times the square root of 2x plus 1 plus, right, since I did the conjugate, 2x plus 2h plus 1, and then times h. So I just chose to write this h at the end. Now in the numerator, what's happening? We multiply by the conjugate. The reason we multiply by the conjugate is to eliminate middle terms. Right, so I'm going to have, when I multiply the square root of 2x plus 1 times itself, the square roots cancel. So I'm just going to be left with 2x plus 1 minus, minus times a positive is minus, and I have more than just a single term coming. I have 3 terms. So I'm going to make use of parentheses. And I'm going to multiply the square root of 2x plus 2h plus 1 times the square root of 2x plus 2h plus 1. So square root of one thing multiplied by itself. The square roots cancel, so I'm just left with 2x plus 2h plus 1. Distribute that negative. So when we distribute that negative, what do we get? In the numerator, I get 2x plus 1 minus 2x minus 2h minus 1. And my denominator will stay the same. So I'm going to call this d for denominator. Just to save a little bit of time because I don't want to write the whole thing out. So I'm going to call this big D for denominator. So d and times h. Right, I'm just calling the stuff in parentheses d. And combine like terms. So 2x minus 2x, those cancel. 1 minus 1, those cancel. And I have minus 2h. So what we're left with is minus 2h over d times h. H divided by h is 1. So we can divide that out. And so our final answer then is minus 2 divided by our denominator. So now for my final answer, I'm going to write out what the denominator was. So it was the 2x plus 1 times the square root of 2x plus 2h plus 1. And again, if you want to use parentheses, use them here to indicate multiplication. You can also use the properties of radicals. These are both square roots, so you can multiply the insides. And then times the sum of those. So 2x plus 1 plus the square root of 2x plus 2h plus 1. We don't have to get rid of all the h's in the denominator. The goal is to get rid of the original h, the h that comes from the formula in the difference quotient. So this h is, the goal is to eliminate this one. Did we eliminate that h? Yes, we eliminated it right here. So the fact that we still have h's on the bottom, that's okay. It's not that original h. So that's the goal, is to get rid of that one. So I hope that this helps. This was, I know in that quiz, this was a little bit convoluted. I am grading using concept-based grading. So if you have little typos, little algebra mistakes, but that won't affect your concept score if the understanding is there. So I hope that that makes sense. Email me if you have any questions.